In this video, I'm going to discuss some concepts about data sets. I'm going to do it a little bit different than we've done in the past with live action screen cam videos. This one is actually going to be a slideshow presentation. And one of the first things I want to talk about are data sets and the differences between them and data readers. From previous videos, we talked about data readers as being connected to a data source, and therefore you can grab data out of them very quickly and iterate through each of the rows sequentially. Now, you can't go back sequentially in the rows, but you can only go forward, and that's a very quick way of getting data from a database into your application. If you want to iterate through it, you'd have to save it off into an array or some type of collection. Data readers are also known as like fire hose connections to the database because they're so fast. However, data sets serve a completely different purpose. Whatever you need to get data and disconnect from the database and then do things to that data, and then at some future point in time connect back up to the database and resolve your changes. There's many reasons why you might want to do this. For example, if you have a component architecture where you're sending data through different components in a data set, you can do this and be assured that you're not going to take the performance hit that you would with the data reader because it's the way that it's passed in the memory regions. So it's for use in completely disconnected situations. We've named one about sharing the data set through components, also sharing it through web services where it can be passed and serialized into XML. And you can also cache data, so you can take whatever your data set has in it and persist it into XML and save it on your database or save it in memory somewhere, and then grab it out of that persisted source and then rehydrate it and use it again. It can contain data from multiple data sources, unlike data readers, so that you can have a table that comes from database A, a table that comes from database B, maybe another table that is constructed purely from scratch, and yet a fourth table that comes from a spreadsheet or some other data source. So, and the neat thing about it is that you can also connect those disparate tables together through the use of a data relation. We'll talk about that in just a moment. And then the changes can be evaluated and resolved back to the original data source. So even though you're not connected to the original data source, it will record all the changes that you make into the data set, and then once you come back at some point and say, I want to save these back into the original data source, it'll take each one of the changes that you made, the log of that change, and try to execute it against the data source. And then obviously the last difference between data sets and data readers is that data sets and the rows can be navigated, so you can go back and forth. You can go to a specific row, and you can't do that with data readers. It's only forward flowing through that set of data. It also can be filtered. You can do select statements within data sets and just get a subset of information. So think of data sets as like a mini database contained in XML that you can do things with, and then if ever in the future you need to take that data and then resolve it back to a database, you can do that as well. Just real briefly want to talk about the class hierarchy for data sets. You'll notice that a data set contains two major collections, data table collection and a data relation collection. The data tables contain columns and contain rows, and then also there's a relationship that's not depicted here between columns and rows, and then constraints, so you can enforce business rules through the columns and rows. Data relations connect tables together, so again, as we pointed out in the last slide, that if you have tables from different data sources, you can enforce referential integrity between those two data tables through the use of a data relation object. There's also the concept of typed versus untyped data sets. Typed or strongly typed data sets, as they're known, allow you to do some pretty neat things, but they do restrict you in other areas. First of all, when we're talking about strongly typed data sets, think early bound data sets. We know the structure of the data table. We know what the columns look like, what their data types are in advance, so that when we're in the Visual Studio.NET IDE, we can use IntelliSense to basically refer to our tables by name. and our columns by name instead of using some type of a string identifier or a ordinal identifier for a given column or table. It also has an XML schema. So if you have a strongly typed data set, you're going to have an XSD file somewhere in your project that holds the structure or the metadata about what that data table will look like. The other benefit of strongly typed data sets, especially in C#, is that it'll catch problems with columns being set to data with the wrong data type at compile time. So if you have a column that can only have integer values in it, if you were to use untyped data sets, it would allow you to set that equal to a string. In strongly typed data sets, it would throw an error before you even got to that point. On the other side of the coin, you have untyped data sets. Untyped data sets are like late-bound data sets. It allows you to dynamically create tables, relations, and columns on the fly at runtime, so you don't know anything about the data structure beforehand, and you can dynamically modify it to your will. Now, there's disadvantages to that. You can't use the neat convention about the table names and the column names like you can in strongly typed data sets. And also, if you're trying to bind controls to them, you'll have to do that at runtime as well. So it's a little extra work from a coding perspective to pull that off. You can't use the neat Visual Studio.NET IDE tools to, like, say, bind a data grid to a untyped data set. But it still has its benefits. And you can, like, for example, you could get a data set from a web service and then infer and save off the schema for future use, but still be able to work with it. And even though you don't know what that data set's schema is going to. In regards to strongly typed data sets, we want to talk just briefly about how they work. And some of this might be obvious to you if you've worked through some of the other videos. First of all, you have the original data source, and that can be a database such as SQL Server or Oracle, or it could be a text file, it could be an Excel spreadsheet, it could be whatever you have the ability to hit using the OLEDDB connection object. Then you have a connection object which actually creates a connection to the database. And then you have one of the most important relationships to a data set, and that's the relationship of the data adapter. Now, if you recall from previous video about data adapters pretty much are the glue between data sets and connection objects. It allows you to grab data from the data connection and store it off in that data set. And then also, most importantly, is that whenever changes are made to that data set, even though it's disconnected for seconds, minutes, hours, days, those changes can be resolved back because the data adapter has built-in commands like SQL command objects that know how to do an insert for objects that were inserted into the data set, how to do updates for rows that were updated in the data set, and how to delete back into the original data source whenever things are deleted from the data set. So at this point, the connection breaks, and it only is resumed whenever your application says, yeah, we need to grab data and save it off, or now we've got a bunch of changes, we need to resolve them back into the original data source. And that's the purpose of the data adapter. The next concept I want to discuss is the different ways that you can use to create a data set. There's a lot of flexibility here. You have a lot of choices to make, and we're going to create videos based on all these different ways of creating data sets. The first way from a strongly typed data set perspective is that you can use the data adapter's generate data set function in Visual Studio.NET. So if you recall, if you're in and you've created a data adapter on your web form or WinForm, there's a little box underneath the property window, and it says generate data set. You can click that, and it will take whatever was the tables and columns that were used in the data adapter. It'll create an XSD schema based on that those tables that were selected. The second way is that you can use the XML schema designer manually in Visual Studio.NET to construct a strongly typed data set. So you can drag and drop tables or elements rather onto the design surface, and they represent data tables. You can create then the equivalent of columns by making sub-elements within your main element that you drag and dropped onto the designer. We have a whole series that deal with using the XML Schema Designer in VisualStudio.net, but we're also going to show how then to do that, create a schema, and then create a strongly typed data set later on in this series of videos. Then how do you create untyped data sets? Well, you can use basically a series of built-in editors in VisualStudio.net to construct the table collection, the column collection, the relation collection, and then refer to that within your code. You can also manually construct the data set structure from code. And that's a very long and arduous process, but it definitely can be done. And we'll show a demo of that in a future video. And then you can obtain an XML document and basically convert it to a data set if some conditions are met. There's no way to get around the inextricable connection between data sets and XML. These are comfortable in either of their skins. And so data sets and schemas can be serialized into XML, and XML and schemas can then be deserialized back into data sets if certain conditions are met, if it's in the right form and things of that nature. And so once the data set is serialized into XML, it can be persisted whether to disk or it can be sent via web service. Finally, that any changes that you make within a data set in its XML representation, you have this concept of diffgrams. And the diffgrams are that to-do list that's kept by the data set to remember, okay, I need to insert a row, now I need to update a row, now I need to delete a row, now I need to insert another row. And it keeps all the original values plus all the new values that should be in the data set. And then that's what the data adapter uses, that list of diffgrams, to coordinate the resolution of the changes back into the original data source. And finally, I just want to talk briefly about data set relations between tables. Basically, a data set relation allows you to connect data tables just like you can relate to relational database tables in SQL Server or Access. It allows you to create constraints. It allows you to create foreign and primary key relationships, and therefore enforce referential integrity between two sets of data. Now the important thing, and we've already mentioned this briefly once, that the data tables don't have to be from the same source. You can still create that, that data relation and force referential integrity between two data tables even though they don't come from the same spot. So that's a very neat way, and it's a very useful and flexible way to manage the data that you have. And it also allows for parent-child navigation from within the data table. So you can have a set of, say, orders and then order items, and you can have both of those tables in your data set. You can have a data relation that connects those two tables together, and therefore whenever, say for example in a data grid, when somebody selects a order, they can see all the order items that apply to that order. And so, like I mentioned here, the WinForms data grid can display this visually in a very nice way. It's a very cool feature, and we're going to do a neat video about that in the future. So I hope this video wasn't too boring. I know slideshow and it's not quite what you're expecting, but these are the only ways that we can kind of talk about at a high level what data sets are all about. And I hope you enjoyed this video, learned a little bit about data sets, and we're going to do probably about 10 or 15 videos in regards to specific things you can do with data sets here in the near future.